Welcome. So I just thought I'd go through question 6 here and just kind of walk it through with you and see how you go with it. All right, so it says, for the curve with the equation this, show that this equation right here is the equation of the tangent at the point a squared plus 3. Hence, find the coordinates of the 2 points on the curve, the tangents of which pass through the point 2, 6. A lot of words going on there. So again, just break it down slowly. What can we do here? Well, it's saying that we have this equation here, and it wants us to show that this is the equation of the tangent. Well, you know, what do you think the first thing we're going to do here is? We're going to differentiate. We're going to differentiate this thing right here, and that's going to leave me with 2x. And then if I'm trying to find the tangent at the point A, at this point right here, well, that means it's when x is equal to a that I'm trying to find the tangent for. So let's go, let x be equal to a, which means I'm going to get 2a. Therefore, the gradient is going to be 2a. Perfect. Now I can write down my point gradient form, x minus x1. To find what my tangent is going to be, I'm going to have to sub in a point. And look, I've been given a point. So I'm going to say let sub in a squared plus 3. We come down here, we zoom in. Stupid thing. Come on. All right, we're going to go y minus. Now be careful, put this in brackets. Equals 2a x minus a. Y minus a squared minus 3 equals 2ax minus 2a squared. Then we're going to rearrange this thing. I'm going to get y is equal to 2ax minus 2a squared plus a squared plus 3, which is going to be y is equal to 2ax minus a squared, because this and this, plus 3. That is going to be the equation of my tangent, and sure enough, if I zoom out enough here, you can see that 2ax minus ax squared plus 3 is what I was given right at the start. So we've shown it. So this is what it means to show, you know. I never used this, but I kind of just worked through the logic and I figured it out. Now it's really important, before we go on any further, it's really important that we understand what we've found here. Notice that we just found the tangent at a point A, and then the y value, of course, is just what happened when I sub a into this. It's just a squared plus 3. So I've really just found like a very general equation. I found a general equation of the tangent. So if we were to picture this, and I think this is where it is helpful to bring in this graph right here. So here's Desmos, and all I've done is, as you can see, I've put in the blue graph is x squared plus 3, and then I've graphed the equation that we just found, which is the tangent. And as you can see, it's just a general form of the tangent. So as a changes, I'm just finding the tangent at different points. I could zoom out a bit here, make it a bit clearer. I'm just finding the tangent at different points. So when a changes, I'm just finding the tangent at different points. So that's kind of what you should have in your head as you're going through this. Now it says, hence find the coordinates of the 2 points on the curve. Hence find the coordinates of the 2 points on the curve, the tangents of which pass through the point 2, 6. All right, so let's say you have no idea what to do. What you should do at this point is just draw yourself a little picture. Whenever you're stuck, just try to visualize what you're doing. So I'm going to come here. I know that I'm dealing with x squared plus 3, so that's going to be here. And then I've got this point. Let me use a different color here. Let's use an ugly color. Gray. No. Purple. Hence find the coordinates, the point 2, 6. Let's put in that. If I had 2 here, and then I sub 2 into this thing right here, 2 squared is 4. 4 plus 3 is 7. So this point right here would be 2, 7, right? So 2, 6 would just be a bit beneath it. I already hate my graph. This point right here would be 2, 6. All right, we need to find the tangent So a line that's tangent to this graph that passes through here. So you can already imagine where it's going to be. So if I use brown, like I'll probably have one about here. If I can try that again, one about here. And as you can see, it just slightly touches the graph there. And I'll probably have another one about, it needs to be tangent to it and pass through that point. So one here as well. So again, you know, this does not have to be pretty. It's just helping us visualize what's going on. So I'm after that coordinate and that coordinate. The coordinates at which my tangent passes through 2, 6. That's what I'm after. So to find that, what I'm going to do is recognize, well, I found the equation of the tangent. I know what the equation of the tangent is. It's just this. So I'm going to take this and sub in the point 2, 6 into it and solve it for A. So I'm going to come here, come here, come here, come here. Let's zoom out a bit. I'm going to sub in 2, 6 into my equation of the tangent. And solve for A. So that means I'm going to put a 6 here, 2a squared minus a squared plus 3. 6 is equal to 4a minus a squared plus 3. I will then minus 3 to get 3 on this side. 4a minus a squared. Let's now bring that actually over to the other side. Let's rearrange this thing a little bit as well. Minus 3. I don't like it when my squared term is negative. So let's just bring everything over to the other side now. So now I've got this. Make sure you haven't made any silly mistakes here. Have I made any silly mistakes? I like my silly mistakes. I don't believe I have. All right, now I'm solving for A, so I'm just going to factorize this thing. So remember, your product has to be 3, your sum has to be -4, and then your factors here. In order to get that, what is it going to have to be? It could be -3 and -1. So A will be -3, A will be -1, equals 0. Because -3 times -1 is 3, -3 plus -1 is -4. A is going to be equal to 3, A is going to be equal to 1. So that means we can find the equations. So if I come over here now, one of them it's going to be A is equal to 3. One of them is going to be A is equal to 1. If A is equal to 3, it's going to be Y is equal to 6x minus 9 plus 3. Y is equal to 6x. What the? My apologies. 6x minus 6. And then over here, it will be Y is equal to 2x minus 1 plus 3. Y is equal to 2x plus 2. Okay, so now that we've done that, what we have found is we've found these two lines. We've found this line and this line. So as you can imagine, this one is going to be Y is equal to 6x minus 6, and this one's going to be Y is equal to 2x plus 2. 2x plus 2. All right, now that I've done all of that and I found my two tangents, so I found the two tangents, but remember what we're actually after here is finding the coordinates at which this is occurring. So we're not quite out of the woods yet. So we've found these points here, but now that we've found these points, I did not have to find these equations. All I had to do from this point is if I know that A is equal to 3, oh, that was silly of me. I didn't have to do that. I didn't have to find these. I kind of just got lost up in the moment there. Thinking about that, I didn't have to find those. I mean, it's great that I have, but it was kind of a waste of time. Because what I know now is that, you know, A is 3. That's going to be here. And A is 1 will be there. So I just need to find the coordinate of that point and that point. So we just did a lot of extra work for nothing there. Because I could have just used that right there. So x squared plus 3. So when A is equal to 3, that means I'm going to take y is equal to, what was the original thing I had? X squared plus 3. Y is equal to 3 squared plus 3. Y is equal to 9 plus 3 is 12. Therefore, the point is going to be 3, 12. And then a is going to be equal to 1. Y is equal to 1 plus 3. Y equals 4. It's going to be 1 and 4. 3, 12, 1, 4. So that means this point right here would be 1, 4. This would be 1, 4. And this point right here would be 3, 12. So that's the points at which the tangent, the point, at that point, the tangent goes through this point right here, 2, 6. All right. We went on a bit of a detour there. I could re-record this whole video again and not go through that detour. But sometimes it's good to see, hey, we just wasted some time. And if you're in a test, you don't want to do that. You don't want to waste time. You want to know exactly what you have to do and how to get there. Okay, that is all. I'll kind of finish here by showing you this, just kind of showing you what we did again. So we had that point 2, 6, and we found, like if we come through this, it looks like right there. Look at that, 1, 4 is the point at which my tangent goes through that line right there. We zoom in a bit. Do you see that? So that's 1 point, so that's 1, 4. But then if I was to keep on going, right there, I go through it again. So I'd have to zoom out again. So this point here should be 3, 12. Bang, and it is 3, 12. And that's what we found. So it's very important that you visualize what you're doing. 1, 4, 3, 12. That's our answer right there. Hopefully you enjoyed this video. Don't be like me. Don't go on pointless detours. Go straight for the answer. I'll see you in the next one.